Good afternoon, children. Welcome to 6th standard online physical science class. So, this is 6th standard physical science online class, continuation of 7th lesson in physics magnetism. So far, we have discussed about the permanent magnets and temporary magnets. Permanent magnets are the one which will not lose its magnetic property for a prolonged time, and temporary magnets are the magnets which loses its magnetic property for a time being. Okay, uses of permanent magnets are used in our daily life in various ways. uh, in the cupboards, doors and windows as catches, and also used as clasps of necklaces, bracelets, handbags, purses, etc. A magnetic strip around the door of a refrigerator helps to shut it firmly. All these applications are based on the attractive property of magnets. The attractive property of magnets is also used to separate magnetic substances from waste. You may have seen rag pickers using magnets attached to sticks to pick up scraps of iron from waste dumps. Motors, generators, loudspeakers, electric guitars, and many measuring instruments have powerful magnets. The power windows and windshield wipers of cars also need magnets to work. The magnetic strips on ATM cards, credit cards, loyalty cards of stores, and airline tickets stores information. Surfaces coated with magnetic material store information in computer hard disk. The directional property of magnet is used in compasses. The directional property of magnet is used in compasses. We know that a magnet always comes to rest in the north-south direction. So by that we may know the other directions also. So the in compasses the needle is made out of water magnet. Okay, children. So far we have discussed the uses of permanent magnet. Now uses of electromagnet, that is temporary magnet. One such important usage of electromagnet is an electric bell. An electric bell, doorbell. How does it works? It has an iron strip, that is hammer, attached to an electromagnet, which get activated when the switch is on, which switch is pressed and attracts the strips. The strip then strikes the gong. So this is the gong. This is the gong. Okay, and the strip then strikes the gong, which produces the sound. Okay, this is how the electric bell works. Okay, children, do you understood this? Apart from this, cranes are used to pick heavy irons made up of electromagnets. Okay, made up of electromagnets, and electromagnets are used to separate magnetic ores from rocks and to separate scrap irons from waste in scrap yards. They are also used in fans, mixers, washing machines, etc. Another important use of this electromagnet is maglev, that is magnetic leviation trains are driven by this powerful electromagnet. In one such type of train, magnets placed between the tracks and under the train have their like poles facing each other. Okay, in these cases the tracks and the under the train, the magnets will be placed, and those magnets faces the has the like poles, and the like poles has to face each other. The repulsion between these makes the train rise and float. Because of the repulsion property, we know that like poles repulse each other. Because of the repulsion property, the train rises above the track and floats. The train is moved forward by electromagnets on the track. Okay, by the electromagnets on the track. These are operated in such a way that the polarity in front of the train is opposed to that of the magnet under the train. Okay, so when you want to stop the train, you can change the polarity, that is pole of the magnet which is under the train, by changing the direction of the current. When the direction of the current is changed, the poles get changed. So now the pole of the magnet which is under the train will become unlike pole to these two magnets in the track. So the train get attracts to the magnet, get attracts, the attraction property plays a role there. So the train gets stops. When you want to move the train, change the pole of the magnet into like pole. That is how this maglev train, that is magnetic leviation train, works. These trains are used in almost all foreign countries. In India, we are planning to bring it to the public usage in a few years. Okay, do you understand this concept, children? Yes, good. So even the magnet should be taken care, so that it won't lose its magnetic property. Even the permanent magnet will loses its magnetic property when it is hammered or heated. So these two things should be avoided, and also it can loses its magnetic property when we keep them in an magnetic field which changes its pole strength, which changes its poles alternatively. So we have to avoid the three in order to keep the magnet carefully, retain the magnetic property of the permanent magnet. And also a bar magnet or a horseshoe magnet can get demagnetized if the poles are left open. This can be prevented to large extent by putting each north pole in contact with the south pole. So north pole and south pole should be contact with each other of the same strength through a small piece of iron. Okay, so by keep placing a small piece of iron, the poles are contact to each other, but they are somewhat separated by this iron piece, and this iron piece are called keepers. Okay, a single keeper is placed between the poles of a horseshoe magnet, and two keepers are used to protect the pair of a bar magnet. The two bar magnets are placed with their north and south poles in the opposite direction. Okay, children, that is how the magnet should be taken care. Now we know that Earth itself acts as a magnet, isn't it? So Earth's magnetic field. Let us learn what is on Earth's magnetic field. Okay, so you have learned that a freely suspended magnet always aligns along the geographical north-south direction. This would make one imagine that there is a giant magnet inside the earth, with its south pole pointing in the direction of the geographical north pole. And so though it is not true, it is a fact that earth behaves like a giant magnet that is inclined to its axis of rotation. There are various complex reasons for this behavior of the earth. Among the reasons is the fact that under its surface lie molten rocks rich in iron. Okay, why the magnet behaves as a magnet? Because the molten iron is present under the surface of the uh, earth. Okay, and molten rocks mainly contain, which are highly rich in iron content. The earth's magnetic field stretches tens of thousands of kilometers into space in a region called magnetosphere. So the earth's magnetic field, it extends to thousands of kilometers in the space, and that region, that magnetic field, is called to be magnetosphere. This field in space protects us from certain radiations from the sun, such as uh, solar wind, and from outer space, that is cosmic rays, and what else, this solar wind are all controlled or safeguarded by this magnetic field alone. When the radiation from the sun, consisting of energetic particles, interact with earth's magnetic field, we see amazing auroras. Okay, the energetic particles from the sun, okay, they react with the magnetic field. We can see something amazing auroras. The northern lights are aurora borealis in the Arctic region, and the south lights are aurora australis in Antarctic region. So this might have this what is, so auroras are the diffusion of light. Okay, you can say ray of lights on the space because of the interaction between the energetic particles and the Earth's magnetic field. Okay, this which is, if it is occurs in the northern region, we call it as aurora borealis. And you know the Arctic region, where the Arctic and Antarctic region lies. If it is in southern region, that is in the Antarctic region, we call it as southern lights or aurora australis. Okay children, so this is about the Earth's magnetic field. So that's the end of this lesson. Hope you have enjoyed and understood the lesson very well children. So do your assignment. Also today onwards we are going to do the revision. So you revise the lesson 6 exercise in physics lesson 6 book exercise should be revised and written a test and get corrected from your parents. Send me the photocopies of the written test to my personal number without fail children. Thank you children. Meet you in the next class.